Welcome back, and thank you very much for watching this video. Finally, we reached the most common question of this chapter. How do I differentiate the mechanism? How do I know whether it's a SN2 or SN1, E2 or E1? Is it SN2 or E2? Is it SN1 or E1? And the first thing that we need to know, when it comes to SN2 or E2, you need to have a strong base or strong nucleophile. So go with strong base or strong nucleophile. And when it comes to SN1 or E1, we will be dealing with weak nucleophile or weak base. And when it comes to a strong nucleophile or strong base, look and see whether there is a negative charge. Okay, and do you have, for example, a negative charge on the nucleophile? And if there's a negative charge, then you will be dealing with a strong nucleophilicity or strong basicity. And so look for negative charge. Okay, let me highlight some of this, factors that you should look for them. The first one is going to be temperature. So first thing, I'm going to go heat. Sometimes we show it by triangle, or sometimes just like, sometimes circle they do, but let's go with the triangle and for heat. If heat goes up, so if you increase the temperature, that's going to favor elimination. And so heat will favor elimination. Why? Because in elimination, and technically elimination is going to be the kinetics product, and it's less stable than the saturated compound, and it's the one that it will happen faster. Okay, faster, and heat will increase the chance of creating those products. Next one is going to be the solvent. Now, divided into two portions. One, call it a protic, and the second go with a protic solvent. A protic solvent is like, for example, acetone. It does not have acidic as in H, and a protic solvent like, let's say, methanol. It has acidic H. Of course, we have two lone pairs in each oxygen. And if it's a protic, no acidic H, the reaction might go through SN2 or E2. Okay. And if it's a protic, in that case, the reaction will go either SN1 or E1. Okay, so the first factor, the second factor, the third factor will be the steric effect. Okay, and steric effect, if you're dealing with a strong base or nucleophile, okay, strong base, okay, slash nucleophile, okay, and when we increase the steric effect, we will be favoring the elimination. So as we go down. Okay, as we go down, elimination, it will be favored. And the third one will have mainly elimination. And if you're dealing with a strong base or a strong nucleophile. And so elimination will be favored, okay, as you increase the steric effect. Okay, next, when it comes to, forgive me, I should say this one. The elimination here, because we have a strong base or strong nucleophile, this is going to be E2. As you increase the steric effect, you go from primary to tertiary, you will mainly get E2 products. Now, when it comes to weak base or weak nucleophile, like what? For example, H2O. That's a weak nucleophile or a weak base. Okay. Again, as we increase the steric effect, I expect to see more elimination of the product. Okay. But when it comes to tertiary, you need to be careful. Okay, tertiary, you have to ask yourself, what do I deal with? Like when it comes to nucleophile, is it strong or like a strong nucleophile or weak nucleophile? Okay, if you're treating this one with, for example, iodide is a strong nucleophile because it has negative charge. Product, main product, it will be SN1. But if you're treating it with, let's say, water or methanol, they have zero charge. In that case, E1, it will be the major product. Okay. Now, how about the steric effect on the nucleophile? Okay. So, steric effect on the nucleophile or the base. Okay. Steric effect on the nucleophile or the base will favor, again, elimination. So, elimination, ratio of the elimination, it will go up. Okay. And that's the last thing that you need to look for it. Let's practice some example. Here, I have an alkyl halide, and the alkyl halide attached to carbon. Clearly, our carbon it has a stereocenter, and is a chiral center technically. So this one is a tertiary. And let's highlight the base. The base is a strong base. Okay, so I have a tertiary carbon and a strong base. And so I'm going to say main product will be elimination. So I get these two products. In the first product, we will get elimination. This is our base does not have any steric effect. So I'm going to say the Zaitsev product will be the major product, and I will have carbon here. That's going to be the Zaitsev product. And what's going to be the second product? The second product, you might get this. So in this case, this one is facing to us. Okay. Now I'm going to switch position of the bromide with the methyl. So we put the OH here, and the methyl, it will go there. Okay, because I switch position of two substituent, and the stereocenter should be opposite. This is going to be SN2. Well, that one was E2. Which one is the major? This is the major product. Okay, let's check the configuration of the starting compound. Was 1, 2, 3. Hydrogen is back. This is going to be S. Here, hydrogen is back. I go 1, 2, 3. This is going to be R configuration. And SN2 reaction goes through inversion inside the stereo center. Another one, we have a base. Our base is a strong base. Is it bulky? No. Okay, no steric effect. How about the carbon? Carbon is a secondary carbon, and this one doesn't have, again, much steric effect. So we get two products. The first product, we can get SN2 reaction. If we get SN2 reaction, this is going to be the product. Bromide is facing to us. I'm going to drive back, so I'm going to replace it by OH. That means this time, hydrogen that was back, now it will be facing to us. So I get hydrogen plus second product will be this one. And I will have double bond here. That's going to be Zaitsev product, and that one it will be product of E2 mechanism. Okay, with which one is going to be dominant product or major product? The major product it will be this. Okay, so as you see, whenever you have a strong base will mainly go through elimination. Why? Because a strong base means less stable. And if it's less stable, it will be more reactive. And so if your base is not patient enough, it will try to get H and it will turn to a neutral compound. Now, what will happen to OH? To OH, if you give it an H plus, it will turn to H2O, and H2O, it has zero charge. So that one, it will be really stable. And that's the reason I say, strong base means less stable, means more reactive. So it will go through elimination. Okay. Another one, we have a primary carbon, and our solvent is a protic. And how about the base? The base, this one is a weak base. Okay. And so this is going to be a weak base. And I will say in this reaction, because it's happening in a protic solvent, mainly is going to go through SN2 reaction. And so mechanism is going to be SN2. And we will get this here as a product, because I have two hydrogens here. And that means I don't have a stereocenter, so I'm not going to bother technically about the configuration of the compound. And just simply say replace the bromide by N3. And also, we're going to say the second product, the inorganic, sometimes they call it inorganic product, it will be bromide or Br with -1 charge. Okay, another example. This case, we have bromide attached to a secondary carbon. Now, our solvent is a weak base, also weak nucleophile. Why is weak nucleophile? Because it doesn't have a negative charge and is already neutral. Okay, so I'm going to call it weak base, weak nucleophile. Okay, now whenever you have such a condition, we say the reaction will go through forming a carbocation, and this is going to be the product of first step. So we will get carbocation here. And remember, we do have hydrogen there. So there is hydrogen here and plus bromide. Next step, this one it will do rearrangement. And we will have hydride there. So that hydrogen will be transferred. And now we have a methyl here, CH3, and a positive charge. This one will react with the solvent. You will take the OCH3 and you will attach it to it. So the final product will be this. This is going to be the final product. We will have methyl. And here we will have O attached to CH3. And okay. And our solvent is methanol. So methanol also it will take acidic H. Okay, but this is going to be the product. And now that's one of them. Okay, one of the product. Okay, and so I got the carbocation. The carbocation went through, like a SN1. It gave me one product. So I'm going to call this one number one. The second product that you will get, you can have this carbocation. So maybe I should copy paste this part, another page. Okay, just say after forming. Okay, copy. After forming this product, sorry, intermediate, we get this. So this is one of the product is going to be. And the second product, okay, your solvent might go after this H, okay, and it will take the H from the system. And if that one happen, so our solvent is going to behave as a base. It will remove that H, and we get this product. We will have a double bond here, plus, again, CH3, O attached to two hydrogens. Okay, and this is going to be the second product, and this is the product of the E1. Well, that one was SN1. Okay, I want to do one more example. Okay, this case I have, let's see, we have a secondary carbocation, a secondary alkyl halide. Our base is a strong base. How do I know a strong base? Because I have a metal, it will have a positive charge, and that one is a negative charge. And so the main product, it will be the elimination, and this is going to go through E2. And because our base is not bulky base, it will give us technically the Zaxo product as a major product. So we'll have a double bond here, and of course we have this methoxide group here. This is going to be E2, and if this reaction goes through SN2, then we will have this as a product. So let's say that this one stays as it is. Nothing will happen to it. Okay, so this one is untouched. But the iodide that was facing to us, now opposite position, we will have OCH3, and hydrogen will be facing to us. So we have now inversion with that stereocenter. Remember, this is a chiral center. So now we have inversion. This one used to be R. Now it's going to be S configuration because it's 1, 2, 3. Hydrogen is facing to us, so it will be S configuration.